Okay, so here we have a circuit, and we are asked to find the voltage across each resistor in our circuit and the current going through our circuit. So this is figure 31.59 in your worksheet. And so what we need to do here, the technique will be to first of all define current, like what direction current is going. And then we will take this circuit here and we will break it down to just a simple circuit where it's just the battery and one equivalent resistor. And then we will work our way backwards to figure out the values that we need. And we're going to organize everything in this table here because it asks us to do that. Okay, so looking at this circuit, remember current goes in the direction of from high potential to low potential. So the current going through the battery is going to be the same as the current going through resistor 1. So we'll call this I1. Once it gets to this junction here, it has three different places it can go. It can go down to resistor 3, so we'll call that I3. It can go down through resistor 4, we'll call that I4. Or it could go down resistor 2, we will call that I2. And then all of them eventually meet back at this junction here and combine to make the total current I1 again. Although it doesn't really look like it, resistor 3, 4, and 2 are all in parallel with each other, and so we could combine those pretty easily. If you don't believe me, I'm going to redraw this circuit here to maybe make it look a little bit more familiar for you. So um, just another way of looking at this. Remember, there's many ways of drawing the circuit, but if I redraw this for you, I could draw it like this. The important thing here is that resistor 1 needs to be in series with the battery. So what I could do is have resistor 1 be here if I wanted to, R1. And for the rest of this, we just need to make sure that R2, R3, and R4 have their own path from resistor 1. So we have resistor 1, and we can make one path going this way, and this could be our R4. This would be another way, or no, I'm sorry, R3, we'll say. And then another path for resistor, this could be 4, R4, and then another path for resistor R2, and then all of them go back to the battery. This is another way to draw what you see here. Okay, just in case this looks confusing, but you definitely want to get used to the way this circuit is drawn. Okay, so to start reducing this, I'm going to combine R2, R3, and R4 so that we get this circuit. If we combine those, we're going to have our 12-volt battery in series with resistor R1, resistors R1. Once we combine those other circuits that are in parallel, we're just going to be left with one, and it's in series with R1. So once we combine R3, R2, and R, so I'll call this R2, 3, 4, then it's going to be left in series with resistor R1, and then we will combine those two. But before we do that, let's figure out the equivalent resistance R2, R3, and R4. So when you combine resistors in series, the way that you find the equivalent is you take the inverse and you add them up. Okay, so 1 over R2, 3, 4 is equal to 1 over R2 plus 1 over R3 plus 1 over R4. Okay, and then we're going to add these up. So we're going to have 1 over, and we said R2 is 16 ohms, 1 over 16 plus we're going to have R3 is 1 over 4, 1 over 4 plus, and then R4 is 1 over 48. Okay, 1 over 48. Okay, so you can add those up with a calculator if you want to. So you'll have 1 over R2, 3, 4 is going to be equal to, I'm just going to use a calculator. So you're going to be left with 1 over 16 plus 1 over 4 plus 1 over 48 gives us 1 over 3, which means that R234, so this means that R234 is equal to 3 ohms. Okay, so now this equivalent here is equal to 3 ohms. All right, the current going through this then is going to be equal to the current that was originally going through the battery in resistor 1. So this is going to be I1 going through this circuit. Okay, so then what we're going to do is combine R1 and R234, and they are in series with each other. And so when we combine that, we're going to have so we have our 12-volt battery, and when we combine that, we just add those up, and so this will finally be our equivalent resistor, our equivalent, and we'll be able to figure out I1 at that point. Okay, so the equivalent then is going to equal R1 plus R234, and R1 is 3 ohms, so we're going to have 3 ohms plus 3 ohms gives us 6 ohms. So our equivalent is equal to 6 ohms. And so now at this point we can figure out I1 using Ohm's law. Okay, so delta V of this one resistor here, you could say delta V equivalent if you want to, is equal to 12 volts, whatever the battery is. And to figure out I1, I'm going to use Ohm's law. So I1 should equal delta V equivalent over R equivalent. And so we are going to get delta V is 12 volts. And then we divide that by R equivalent is 6 ohms, and that gives us 2 amps. Okay, so we can go up to our table here, and we know I1 is 2 amps. 2 amps. Okay, so now we know some information here, and we can start working our way back up our circuit here. Okay, so here's what we know about R234. We know that the current going through that circuit, and we know the resistance is equal to 3 ohms. Okay, and so what we can do is figure out delta V of 234, how much voltage is going across that that component, and that's going to equal the current. So we said I1 is 2 amps, and so we're going to have 2 amps times 3 ohms, and that's going to give us 6 volts. Okay, this is an important value. I'm going to wait for that for just a minute, because what we can also figure out then is the voltage of R1. Okay, 2 ways to do that. We know R1 and we know the current going through it, so we could use Ohm's law, or we know that the sum of the voltage as we go around the circuit, it must equal 0. So if we start with 12 volts, we need to end down to 0. So 12 volts for the battery minus the voltage of R1, which is what we want to find, minus the voltage of R234, which is 6 volts, should equal 0. So that means that R1 must be 6 volts also. So R1, we'll go ahead and put this here, it must be 6 volts. Okay, working our way back up to this circuit, well, let's go back to the original circuit. I just kind of drew this circuit here to show you that it's the same as the original. But what we know is that the voltage of this equivalent resistor 234 is equal to 6 volts, and components that are in parallel to each other all have the same voltage. So what we can say then is that delta V of 3 and 4 and 2 all have to be equal to 6 volts. All of them equal 6 volts. So we'll go ahead and write that in now. So R2 is 6 volts, R3 is 6 volts, and R4 is 6 volts. So now we need to figure out the current of each of these, and we know the resistance and we know the voltage, and so we just use Ohm's law for each of those, okay? So I'm going to do that work over here then. So for resistor 2, it's 16 ohms, and so the current, so I2, is going to be the voltage across that resistor, so delta V2 over R2, and that's going to give us 6 volts divided by 16 ohms. Okay, and you can just leave this as a fraction, just reduce the fraction a little bit, or you could put it in as a decimal if you want. So you could leave it as 3/8 if you want, 3/8 amp, or if you put that in your calculator, that would be 0.38 amps. You could use either one. I'm just going to use the decimal for now, so we have 0.38 amps. I3 is going to be delta V3, which is 6 volts, divided by 4 ohms. So the current through that resistor, 6 divided by 4, is going to give us 1.5 amps. 1.5 amps. And then the current going through resistor 4, so I4 is going to equal 6 volts divided by 48 ohms. 6 divided by 48 is going to give us 0.13 amps. Okay, so our data table is filled out. The last thing to do is just to make sure that our work is good. So two ways that we're going to do that. One way is we're going to make sure that delta V, we want to make sure that delta V of the circuit equals 0, okay? So let's just check that out here. So we have 12 volts from the battery. Okay, we always have to go through resistor 1. So 12 volts for the battery, and then we're going to have minus R1. So that's 6 volts. So now we're down to 6 volts. And either path that we take has to take away 6 volts, and it does. Either if we go down the path of R2, for example, we're going to minus another 6 volts. Okay, current keeps going. It doesn't go up potential, right? So it won't do that. It's going to keep on going back to the battery. Okay, so no matter what, we end up at 0. So that's good. And then the other thing that we can check is will I1 equal, I1 needs to equal I2 plus I3 plus I4. So we can check that here. We have I2, we said was 0.3 amps. 0.3 amps plus I3 is 1.5 amps. 1.5 amps plus I4 we said was 0.13 amps, and we need to check, does that equal I1? Does that equal 2 amps? So our answer may not be exact, and that's because I didn't put them in fraction form, which that might be the advantage of doing that. So we have 0.38 plus 1.5 plus 0.13 gives you 2.01. So close enough. If you leave it in fraction, if you leave that in a fraction, it'll be fine. So it ends up equaling about 2 amps, which is good. That's what we want it to equal. So a couple of things, just make sure that you check your work when you're done. If something did not work out, if either when I check the current, if that doesn't work out, or if I check the voltage and that doesn't work out, then I made some kind of mistake here. And just be careful that you follow the rules. If resistors are in series, they share the same current. If they are in parallel, they share the same voltage.